Okay, for 51, Wesley, let's read.
A particle moving or moves along the x-axis so that at time t is greater than or equal to 0. The position of the particle is given by x of t equals 0.5 t to the power 4 minus 1.5 t to the power 3 minus 2t squared plus 6t minus 1. What is the velocity of the particle at the first instance the particle is at the origin?
Okay, the velocity of the particle. Is that our first derivative or second derivative? First derivative. So I'm going to give you a little calculator trick. When you go to math number 8, let's all go to it together. Go to math. The number 8 says derivative. And we have some function on there. So let's find out what that number is going to be. At the origin of 0. Actually, that's our second portion. On the first thing that we're going to do, the origin is when y is equal to 0 and also x equals 0. I'm going to put it y1, 0. And this complex equation on our second one. And we're doing this trying to figure out what is my x when y1 hits 0 to the power of 4 minus 1.5 x to the power of 3 minus 2x squared plus 6x minus 1. Let's make sure the numbers are correct. Okay, once you have this, go to Zoom 6. And it should cross one of them. Okay? So it's crossing out what number as we can see. Second calc 5. I can go to the first one over here. Or the next one. It wouldn't really matter. Okay, we got x equals how many on the first one? 0.17. How would I round that? 9. Do y'all see that y is equal to 0 as we anticipated? So this is our magic number. So not sure if I covered this this year or last year when I used to teach pre-cal. Go to your home screen. The cool thing about when you calculate something with the intersection, when you type in that x, it's going to recall that number. So we're not rounding as we go, because you don't want to round that number. Okay? So using our function on math 8, let's all go to math number 8. With respect to x at all times, we're going to plug in this equation. Squared, nope, to the power of 4. The powers are going to mess me up big time. Power 3 minus 2x squared plus 6x minus 1. And we're looking at the value at 0.179. Didn't I just type in or recall the x anyways? So I can plug in x. It's going to say, remember the previous number is what we're plugging in. And it'll actually calculate it. And it's got 5.153. Boom.
Could you do any of that though?
What's that?
Could you do any of that though without if you had clean numbers?
If you have clean numbers, elaborate on that.
Like, I just don't see how you could do any of that without like a calculator for the most part.
Just get the idea of it. I still want to, I'd rather y'all get exposed to as much as possible on the review, and then exam be a little more relaxing, if that makes sense. Okay? Let's go on to number 52, right? Okay, on number 52. Anna, let's read.
Two particles start at the origin that move along the x-axis. For 0 is less than or equal to t, which is less than or equal to 10. Their respective positions are given by x1 equals sine t and x2 equals e to the negative 2t minus 1. For how many values of t do the particles have the same velocity?
Okay, same velocity. So I have to first derive this. So when I derive the first piece, I'm just going to write x prime. What's derivative of sine? Cosine. And then for the second one, okay, second one's a good practice for deriving the e. E to the whatever is itself times the derivative of the power, right? So it is this itself. So copy that as it is. Times the derivative of that. What is the derivative of that? Negative 2. So we're going to put this into y1 and y2 and figure out when they cross each other. It's kind of like finding the solution back in algebra 1 or 2.
How would we do this without a calculator, though? Isn't it? We don't get a calculator, right?
It's a concept.
I still don't get it. Okay, continue. I'm sorry.
Okay, without a calculator, it'll be doable for you to equate them with each other and you solve for the variable. This one's not.
Oh, like you make like y. You make
Yes, you
y
set them
y.
equal to each other and you solve for x, or in this case, t.
Okay.
Okay, I don't want to hear anything about complaining with the calculator anymore. It's not making me happy at all. I'm going to put the coefficient of negative 2 in front because I feel like it. Then we have negative 2. Oh, that's not 2. And I'm going to make sure my mode is on norm. It is. Okay. Let's go to Zoom 6. Does it make sense my cosine is speaking is actually a wave?
Yeah.
Yeah? So it's crossing at 1, 2, and 3, and I'm going to do a quick sketch. So the graph is going something like this. And then the other one is going something like this. And I want to figure out what numbers are these. So we have second count, 5.
Yeah, numbers on
Oh, we don't need the number up. How many? 3. Boom. I guess reading the answer should be smart like I told you guys last week. All right, 53. Hobart, let's read.
Let f be a function with the derivative given by f prime of x equals x cubed minus 5x squared plus e of x, on which of the following intervals is the graph of f concave down?
Okay, there's 2 ways to look at this. The first way would be not doing any work. Second one is going to be actually doing work. So here's the idea. If f double prime is negative, it is concave down, correct? But don't we already have f single prime given to us? So we're looking for when f single prime is going down, then I know the function is concave down. So let's actually graph this. If you want to take it with a negative value, go for it. But there's many ways to find the answer. I want to just plot this. X to the power of 3 minus 5x squared plus e to the power of x. And I'm going to sketch this to the best of my ability. The graph is doing something like this. And it's going up and down and up. And we are looking for when f prime is going down. F prime is going down between these 2 intervals. Is that correct?
Yeah.
So I need to figure out what is a max and what is a min. And by that I mean the x value of max and min. So second calc. Our max is button number 4. And it says go to my left, enter. Go to my right, enter. And it's going to say, well, do you want me to really calculate? Always yes. So my x value on this one is 0.116. For my second one, I need my min. Option 3. To the left from the bound, right from the bound. Do I want to calculate? It's always yes. So my x value of this is 2.062. And that interval has to be option number or letter C.